Hi, thank you for having me to the 3D printing meetup this evening. My name is Eric Pinkel, and I am a project designer at Macrovision Corporation. And we are working on a 3D printed drone project for this year's Autodesk University. And I just came tonight to talk a little bit about the project and some of the ideas that we're putting into it. So let me just get started. So our team, the main concept for our project is to build a 1,500 millimeter quadcopter, which is quite a large size quadcopter, and then to essentially skin it with a thin 3D printed ABS exoskeleton that then screws into the frame and flies like a prop using off-the-shelf DIY technologies and things that other people can produce similar to us. And so ours is an open design project, and that means that the final product will be free, which means the technology and the building and the CAD files and everything that we're doing in concert to create this UAV will be in an open source format and shared with others, so that you could in fact build your own version of what we're making. And so that's the exciting thing. So our project is really based on creativity and CAD and community. So binding those three things together to make something new and interesting and unique is really the challenge that we kind of undertook as a company. Just to give you an idea, we're partnering with lots of different companies who invest in new ideas and that are, essentially just donating to us pieces and components of the things that they manufacture and make. In the case of Monto RC Hobby, they provided us with the heavy lift engines. Maker Geeks, who is an awesome company, they are basically supplying us with our 3D printer. So obviously everyone here is interested in 3D printer. The printer that we're looking at is called the Zion printer, and it's a 16 by 16 large format 3D printer, and it is an amazing product. So they're going to allow us to use one, and going to be shipping that out to us, and we're going to make the videos of how we're constructing it as we print it and assemble it in the coming months. So we're also partnershiped with the tech shop. So the tech shop is an awesome place. They have 3D printers there. Nothing in the scale that we can use, but they have great technologies that allow DIY builders and people that do their own crafts to go and access an entire shop of tools and laser cutters and 3D printers, and Autodesk is there giving amazing talks about the software and CAD software. I mean, it's really an amazing place. And so I was fortunate enough to be sponsored by them, and I'm getting down there on a weekly basis, and have met some just incredible people. So this gives you an idea about our airframe, and this shows essentially how the 1,500 millimeter final airframe will look. And we're lucky enough to have Eric Nattel on our team, and he's a great 3D designer, and is helping us come up with the feel. We're inspired by his design, so that gives you an idea. And then we're also using all Autodesk products for our design. That's another reason why we're submitting to Autodesk University. Autodesk Fusion 360, Autodesk 3ds Max, which we're doing the exoskeleton in, and actually Sketchbook Pro to get the ideas on our phone, and go from there. And there's plenty of other people out there that are doing similar things that we're doing. So here is an example of a very similar type of project that was done in China. This particular project was made with paper. Our challenge will be to see if we can do a similar type of project with thin-walled ABS printed plastics, and it's an exciting challenge. So just to go over the project just a little bit more quickly, we provided this at the tech shop as a kickoff early in the year. And this is a presentation that we made for the kickoff, so you can get an idea of what we're doing. So that's just a little bit of introduction about me, creative 3D professional and visualization and effects. The Medusa project, community-based design build, multi-rotor VFX UAV for Autodesk University 2014. Again, the three principles: creativity, CAD, and community, and how we're connected together. So we plan on, Autodesk has just opened its submissions. We plan on writing a paper about teaching the different classes that show how we used to build it, and then hopefully, if the proposal is accepted, we were trying to fly the UAV in the auditorium. And you know, the idea is that it's very much for show. Obviously, it wouldn't be that scale, and it would be, you know, set down on the stage closer. The idea would be to fly it with a heads-up display, and then have cameras that see the audience, and then play that loop back through to the big screen. That's kind of a fun presentation style. We've looked into handheld lasers, and you know, so we can scan the audience, you know, without hurting them. And then obviously, you know, there's plenty of inspiration out there, and so we're kind of blending the concept between the Matrix and the HK Hunter Killer. So that came kind of feel with like cables and so here's an example of what we're going to do. So here's the carbon fiber frame, or the G10 frame, and there is the 3D printed exoskeleton. So that product is already available on the web for a small size. We'll paint it then. Some of the things is it really must fly with off-the-shelf components, and we're building a 2-size PVC prototype that will allow us to test the geometry and the flight configuration before we actually print it. So here's it's cut out. This will be cut out of the material, and that's what we'll design. So I've done quite a bit of research on the RC forums using the calculators to estimate what the total lift capacity will be for these particular engines. Here's a basic configuration of what we're using for our power system to lift the large plastic surface model. 1500 millimeter is quite large. Again, our idea is to build a PVC prototype first, a 2-scale PVC prototype.